I have this JMU block model in CAD. I want to 3D print it. The first thing I need to do is create an STL file, structured triangle list. I'm going to click on Utilities. I'm going to click on Make. I'm going to deselect Send to 3D Printer Utility. Up here, this select is highlighted blue. I'm going to select the model and click OK. I'm going to save this to the computer. Now I have installed and opened Ultimaker Cura. This is slicing software that you can use. If you're familiar with the different slicing software and you know what you're doing and want to give that a try, that is fine. There are two things that I need to know to start using this software. The first is what printer I'm using, and the second is what material I'm using. In Cura, I'm going to go to Settings and Printer. I'm using a Creality Ender 3 S1 printer. If that's not listed here, I can go to Add Printer, select Non-Ultimaker Printer, select Add a Non-Networked Printer, scroll down to Creality 3D, and select the Ender 3 S1 and click Add. The other setting is the material. This printer only has one extruder, so I'm going to go to Extruder 1, Material, and select Generic PLA. The other material that we have in the lab is PTIG. If you're using that material, be sure to select it. It will have different settings, but the majority of the material we have and are using on the printers is PLA. Now I'm going to click File, Open Files, and in Downloads I have the JMU block. So as you can see, here is a button to slice. But first, let's look at this block. If I select it, I have the option here to move it to a different place on the build plate. If I was doing several different files, I might want to arrange them that way. I can also rotate this block. I can either click on the arrows like that, or I can click and drag. I can also scale the block. One thing you might run into is that you created a model and it appears to be a completely different size in Cura. That could be because of one program using inches and another using millimeters. So if your model appears to be very, very small, you might try putting in 25.4 millimeters per inch times 100% into, let's say, just the x-axis, and hit enter. It'll put the same number on all three axes, and you can see if your model looks to be appropriately sized. This model is a 1/2 inch cube, and it looks to be appropriately sized here. Now I could go ahead and slice and print this model. However, the printers that we're using, the Creality Ender 3 S1 printers, have a bit of a problem with the z-axis when you start a print. For that reason, I want to use some custom settings. If I come over here and drop this down, I have access to more settings. And I can even click Show Custom, which gives me even more settings. The quality, I don't need super quality on this print. I'm going to select dynamic quality and say discard changes. If what I was printing was fairly large, I might go with low quality. It depends on how much time I have for the print and how much material I can use. On infill, 20% is fine for most all prints and will certainly be fine for this print. There are many different infill pattern types. I like cubic. For build plate adhesion, this is perhaps the most important setting. There are different types of build plate adhesion. I would definitely use a raft on these printers, so I'm going to select that. But I want to show you the different types of build plate adhesion. So first we'll use skirt. I'm going to slice this. Once it's sliced, I'm going to click on Preview. The skirt is this bit of material that it prints around the object. Changing that to brim. Slice that. And here in the preview, you can see this brim, like the brim of a hat, material around the object. But I'm going to use raft. And it basically prints a thick brim that's assembled sort of like a pallet. And that helps deal with the imprecise z-axis on these printers. Another thing I want to look at is support. These are FDM printers, fused deposition modeling printers. One way to look at it is that they print like you would decorate the top of a cake with a tube of icing. You're extruding icing out of the nozzle and forming a bead of icing on the top of the cake. That would be the first layer that they put down, that the slicer puts down. Then you would be building up layer after layer of these beads of icing on top of the cake. This is why this software is called a slicer. It's taking the model, slicing it into layers, and figuring out where to extrude the plastic on each layer and building up those layers. If we look at this, we can see that there are parts of this model where plastic is extruded over air. There's nothing to support it, and it's highlighting those areas red. If I try to print this model, I will probably end up with what looks like a tiny ball of spaghetti. So here under support, I'm going to say generate support. So I could have normal support everywhere. If I slice that and look at the preview, here's what it looks like. I've got support all inside these letters and all inside the inside of this. That will work, but it will be difficult to clear that support material out. Instead, if I can, I prefer to use tree support and touching build plate. If I do that, you can see it generates these tubes of support that sort of look like trees that are easier to clear out and use less material and usually have a faster print. Now again, if you don't have to use support, I would recommend that you don't use support. But if you do have to use support, usually this algorithm works the best. Now I have to transfer these instructions to the 3D printer. To do that, I'm using an SD card and an adapter to plug into a USB port on this computer. There are adapters in the drawers on some of the printers, and each printer should have its own SD card. When I insert that card and adapter, the save to disk changes to save to removable drive. Before I do that, I'm going to edit this name. And save this as JMU block. Also, I'm going to look at how much material and how much time this print takes. This print is going to take 29 minutes and use 3 grams or almost a meter of material. If this is too much time, I might try using lower resolution. If this is too much material, I would likely change the size of my print. I'm going to go ahead and save this to the removable drive. And once it's saved, I'm going to eject. Alright, I'm going to run the print on this printer. As you can see, the printer has run out of material. This senses when material is present. So I'm going to load more material. First, I'm going to make sure that the material I'm using matches what I sliced, in this case PLA. I'm going to push down on this lever and pull this material out. I'm going to load the new spool of material, run it through this sensor, push down on this lever, and make sure that the material goes down in there fairly well and doesn't pull back out. I'm going to turn on the printer. I have the SD card. I'm going to insert that into the front of the printer. On the build plate, there's this magnetic sheet that comes up. If there was someone else's print on here that had finished, I would take that print off. I can use one of these scrapers, setting this on a hard surface to try to scrape off any excess material. As you can see, there's some residue of glue on this build plate. I'm going to put that back on here. I want to have glue wherever my print is going to take place. So if it looks like there's not much residue left, I can go ahead and add a little bit more. This will just make it a lot easier to separate the print from the build plate and also help the print adhere. The interface on the printer is not a touch screen. All action is through this knob and button. I want to print, so I'm going to go ahead and select that. I'm going to use the knob to scroll down to my print and select it. And the printer will start heating up the nozzle and build plate in preparation for the print. About 8 minutes have gone by and the printer is warmed up and ready to make a print. But I'm going to wait a few more minutes to make sure that the raft starts correctly. A few more minutes have gone by and I can see that the raft is doing fine. There's material all over the area. It's not stringing up or peeling off of the build plate. So at this point I'm going to leave and let the printer finish the print.